Hi students, good morning. My name is G. Kavita and I am an assistant professor of physics in Erode Arts and Science College. Today now we are going to say about electrostatics. Students, first of all, before we enter the topic, we should know about electrostatics and also some definition. So basically, what is mean by statics and dynamics? Okay, statics is the study of internal and external forces in a structure. Okay, statics is the branch of mechanics that deals with the bodies at rest, mainly rest. Okay, the study of system in which momentum does not change is called the statics, and dynamics involves the study of changes in momentum. Students will come to the point electrostatics. Electrostatics is a branch of physics that deals with the phenomena and properties of stationary or slow moving electric charges. Okay, so electrostatic phenomenon arise from the forces the electric charges exact on each other. Okay, electrostatics is the study of the interaction between stationary electrically charged particles. Electrostatics laws deals with the attractive and repulsive forces that exist between positive and negative electric charges. The electrostatic force is an attractive as well as an repulsive force caused by electric charged particles. So it is also known as Coulomb's force. This diagram shows that structure of nucleus. Okay, nucleus means is the central area of the atom. Okay, it is composed of two kinds of subatomic particles, one protons and another one neutrons. Atoms are the building blocks of all matter. Everything you can see, feel and touch is all made up of atoms. There are even things you cannot see, feel, hear or touch that are also made up of atoms. Basically everything is made up of atoms. The atomic nucleus is in the center of the atom. The number of protons and neutrons in the atom define what type of atoms or element it is. Okay, an element is a bunch of atoms that all have the same type of atomic structure. For instance, hydrogen is an element. The composition of the atomic nucleus gives us lots of information about the element it presents. The number of protons inside the nucleus gives us the atomic number. The proton have a positive charge. In order for the atom to have a neutral charge, the electrons need to balance it out with that negative charge. Therefore, in a neutral atom, there are just as many protons as electrons. So, if you know the atomic number and know the charge of the atom, then the number of electrons is easy to find. For instance, hydrogen has one proton, one plus. So in order for the hydrogen atom to be neutral, it must have one minus charge. Therefore hydrogen has one electron. Okay, where do the neutrons fit in all of this? Well, neutrons are neutral. To keep it all straight, I use the first letter. Neutrons are neutral and protons are positive. I then remember electrons through the process of elimination. Okay, um, location of the proton is inside the nucleus and charge of the proton is 1.6 into 10 power minus 19 coulomb, and mass of the proton is 1.67 into 10 power minus 27 kg, and the electron present is the energy levels, and charge of the electron is minus 1.6 into 10 power minus 19 coulomb, and mass of the electron is 9.11 into 10 power minus 31 kg, and the neutron having no charge, and mass of the neutron is 1.68 into 10 power minus 27 kg. History of electricity. Electricity would remain little more than an intellectual curiosity for millennia until 1600, when the English scientist William Gilbert wrote De Magnete, in which he made a careful study of electricity and magnetism. distinguishing the loud stone effect from the static electricity produced by rubbing ampere. He coined the new Latin word electricus. Okay, ampere or like ampere from Greek word to refer the property of attracting small object after being rubbed. This association have rise to the English words electric and electricity, which made their first appearance in print in Thomas Brown and Pseudodoxia Endemia of 646. Okay. Further work was conducted in the 17th and early 18th century by Otto von Guericke, Robert Boyle, Stephen Gray, and C.F. Dubé. Later in the 18th century, Benjamin Franklin conducted extensive research in electricity, selling his possessions to fund his work. In June 1752, he is reputed to have attached a metal key to the bottom of the damped height string and flown the height in a storm threatened sky. A succession of sparks jumping from the key to the back of his hand showed that lightning was indeed electrical in nature. He also explained the apparently paradoxical behavior of Leyden jar as a device for storing large amounts of electrical charge in terms of electricity, consisting of both positive and negative charges. Next, developed the concept like charges repel and unlike charges attract. Okay, what is mean by charges? Okay, flow of electron is the charges. Flow of charges is the current. Okay, this concept like charges repel and unlike charges attract. Scientists found that charged object will either attract or repel another charged object. Two objects with the same charges will repel each other, and another two objects will the opposite charges will attract each other. This is summarized in the law of attraction and repulsion. Unit of charge is coulomb. So how to came Coulomb's law? In 1785, for the first time, a French physicist named Charles Augustin de Coulomb coined in a tangible relationship in the mathematical form between two bodies which are electrically charged. He also published an equation for the force causing the bodies either to attract or repel each other, which is called the Coulomb's law or Coulomb's inverse square law. Okay, what is an electric charge? We already discussed about charge. Charge is the flow of electron. Okay, an electric charge is the electrical property of matter that creates force between objects. The attractive or repelling behavior of the material. Next concept is net charge. Net charge is the sum of an object charges. Most objects have zero net charge. The charge is neutral. Okay, neutral objects contain equal positive and negative charges. The first diagram show that before process of attraction between glass rod and silk cloth, and the second diagram show that after process of attraction between glass rod and silk cloth. Another important concept is conservation of charge. Electrical charge can be neither created or destroyed. It can be separated and moved around, but the net charges of an isolated system must remain constant. Charge initial is equal to charge final. Okay, for example, a plastic rod is rubbed with wool, each initially neutral. Then charge of the wool is equal to negative charge of the rod. Okay, this diagram explain rub the plastic rod with a piece of wool. And another example is when we run a piece of paper with the oil in our head with the help of comb produces electrostatic force. The diagram explained charging a single sphere by induction. Okay, let us take a negatively charged rubber balloon. If we bring the charged balloon Near the sphere, electrons within a two-sphere system will be induced to move away from the balloon due to the repulsion between the electrons of the balloons and the sphere. So first diagram is a metal sphere is mounted on a stand. Okay. So second one is explained. If we bring the charged balloon near the sphere, balloon induces the electron movement from the left side to the right side of the balloon. And third one is when they touch the electron, leave the sphere through the hand and enter the ground. And fourth one is the sphere is now charged positively with the excess charges attracted to the balloon. And fifth one is the positive charge evenly distributed itself over the sphere. So next important one is conductors. Any material that allows electric current to pass through it. Okay, for example, copper, aluminium, steel. What is the reason for conductors? The energy gap is overlap. That means that part of conduction band inside valence band. Because of that, we find conduction electrons in conduction band. Use it is a good electronic conductor. There are some conductors have very narrow energy gap, and we find conduction electron in conduction band. And next one is insulators. Any material that does not allow electric current to pass through it. Okay. For example, plastic, rubber, glass, cloth, wood. Okay. The reason of insulator is there is a wide gap between the conduction band and valence band. This gap is forbidden area for the existence of electrons. Thus, the conduction band is empty of electrons. That is what makes it insulated on the electrical conduction. I was forget one thing, semiconductors. So semiconductors means partially conducting. Okay, for example, silicon, germanium. So the gap between the conduction band and valence band is narrower, but at small degrees of heat, electrons move across the gap to the conduction band and become conductive material, but at a temperature of absolute zero, it's behave as insulator. Okay, the difference between conductance and insulator is conductor is those substance through which electrically can flow are called conductors. Electrical resistance of conductors are very low and they contain large number of free electrons. Generally metals are conductors. Okay, for example, silver, copper and aluminium. And property of insulators is those substance through which electrically cannot flow are called insulator. Electrical resistance of insulators are infinitely very high. They do not contain free electrons. Generally, non-metals are insulators. For example, wood, rubber and plastic. Okay, this is an electroscope. This electroscope is an early scientific instrument used to detect the presence of electric charge on a body. It detects charge by a movement of test object due to the Coulomb electrostatic force on it. The amount of charge on an object is proportional to its voltage. Okay, electroscope instrument for detecting the presence of electric charge or of ionizing radiation, usually consisting of pair of thin gold leaves suspended from an electrical conductor that leads to the outside of an insulating container. In 1748, Nullet invented one of the first electrometer, the electroscope. The symbol is the electroscope is neutral as evidenced by the needle in a relaxed position. Okay, finally, Coulomb's law. Coulomb discovered an inverse square law like gravitation, except that of course like charges repelled each other. The force acted along the line of centers with a magnitude proportional to the magnitudes of both charges. Okay, generally Coulomb's law states that force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So the formula is F directly proportional Q1 Q2 and inversely proportional to the r square. So remove proportional and add constant k. So k is the constant of proportionality. F is equal to k q1 q2 divided by r square. So F is this force between charges q1 and q2, and q1 is the charged particle, q2 is the another charged particle, and r is the distance between center of the charges, and k is the constant, equals to 8.99 into 10 power 9 Newton meter square per coulomb square. Okay, thank you.